Hello, my name is Derek from Tomcat Gas Training, and today's video you're about to watch is a gas tutorial for trainee gas engineers on FLUE flow test and spillage. The appliance we're going to be working on today is this radiant gas fire. And the first thing we're going to do is we're going to be doing a FLUE flow test. So let's have a look at that now. So before we visually do it, let's see what British Standards 5440 Part 1 says about a FLUE flow test. Now, the first thing we must do with any chimney is a visual inspection. So whether it's a precast flue, a brick chimney, or even if it's a combi boiler, we should still be visually checking our chimneys or flue systems. So 5440 says, the chimney, whether existing, newly erected, adapted or altered, shall be visually checked before fitting an appliance to ensure that it is fit for its intended use with the intended appliance, and is unobstructed, complete and continuous throughout its length, serves only one room or appliance, has the terminal correctly sited in accordance with 6.15 and a weather-tight joint between the terminal and the chimney. Any dampers or restrictor plates have been removed or permanently fixed in the open position to leave the main part of the flue unobstructed. Any catchment space is the correct size, free of any debris, and any gaps into the catchment space are sealed from the surrounding structure. Where an existing chimney is being used, any signs of spillage shall be investigated and faults rectified. So that's the visual checks what BS 5440 say. So let's have a look now at the actual procedure. So BS 5440 Part 1 says for your FLUE flow test or your smoke test, on satisfactory completion of the visual checks in accordance with 6321, the FLUE flow shall be carried out as follows. Having established that an adequate air supply for combustion has been provided in accordance with the appliance requirements, close all windows and doors in the room in which the appliance is to be installed. Carry out a FLUE visualization check using a smoke pellet that generates at least 5 meters cubed of smoke over 30 seconds. Burn time at the intended location of the appliance. Ensure there is a discharge of smoke from the correct terminal only and no leakage into the room. Where the chimney is reluctant to draw and there is smoke spillage, induce some heat into the chimney for a minimum of 10 minutes using a blowtorch or other means and repeat the test. When the chimney is tested in accordance with A and B, there shall be no significant escape of smoke from the appliance position, no seepage of smoke over the length of the chimney, and a discharge of smoke from only the correct terminal. So that's what the FLUE flow test is to BS 5440. So let's put this into practice. Let's have a go now. Now, the first thing we've got to do according to BS 5440 Part 1 is we've got to do a visual inspection. So we need to remove this appliance. Now, removing this appliance is incredibly easy. The first thing we've got to do is get this front cover off. So that's the front cover off. Now, what we've got here are 2 screws here, okay, and the gas connection here. Now then, let's talk about tightness testing. Now, according to the gas installation and use regulations 26.9, it says when carrying out a service you do not need to do a tightness test basically. Now, as a new entrant into the industry, I would be telling you guys to do tightness tests all the time, because one thing you want to do when you go home is sleep at night knowing you haven't left a gas leak. Now, what we could technically do in this situation is there is an isolation valve down at the bottom here, so we could turn the isolation valve off and disconnect at the nut holding onto the fire without even turning the gas off. Okay. Now, I would say you should do a tightness test first and a tightness test after completion, knowing one, you haven't got a gas leak to start off with, and knowing two, that you can sleep at night because you know you've not left a gas leak. So my first advice would be do a tightness test first, whether you're servicing, commissioning, installing, you've got to do that anyway, but if you're servicing appliance, now do a tightness test. Now on this fire it's incredibly easy to disconnect, but if you think you've got an inset live fuel effect fire or a DFE fire where you're actually pushing something in, or you can't see the gas pipe work, you don't know whether you've disturbed it putting it back, but a tightness test will tell you that at the end. Also purging. So after a successful tightness test you've got to purge. Fires need to purge them all the time because they don't light very well unless you do purge them. So yeah, do a tightness test first, do a tightness test after, but remember after a successful tightness test you've got to purge. So technically you've still got to spray the nut you've done because you're not going to do another tightness test. Anyway, that's over and done with now. Do a tightness test first, do a tightness test after. When we look at the procedure you'll see how easy it is. So let's get on and disconnect this fire now. Now, I've undone the connection at the bottom, slackened these two screws off here at the side. Now, before I take this fire off, I'm going to remove the radiants. Okay, so the radiants are these little things, these little puppies, and these are part of the FLUE system. Made of silica, very, very delicate. Be very careful when removing and placing these somewhere safe because they are so delicate. If one of these is broken or damaged, it would be, in our unsafe situations procedure, IGMG 11, it would be deemed at risk, and if it did fail its spillage test, we then would be saying it is immediately dangerous. So if it fails its spillage test, it would be immediately dangerous. If it passed its spillage test and you didn't get any smoke coming out of here, we would be at risk in it anyway. So broken radiants, make sure you check them, make sure you keep them safe. I'm going to put them up there on the shelf so they don't get broken. Now, easy now just to lift it off because I've slackened the screws off. So now, what we've got here is what's called the closure plate. The closure plate is the one the manufacturer sends with the fire. Don't use just any old piece of metal, but if you do have the manufacturer's instructions, remember British Standards 5440 says you can't service, repair or install a gas appliance without the manufacturer's instructions, and if you haven't got the manufacturer's instructions you must consult the manufacturer. They do give you a drawing where it gives you all the measurements, so you could get a blank, you could cut them out to the manufacturer's instructions. There are two holes in this plate, one down here which is called the air relief hole. Now the air relief hole is a set size by the manufacturer, and again you must check with the manufacturer's instructions to see what size this hole is. And what this does is it allows air in to aid, draw and dilute the products of combustion. And this is what we call the letterbox opening, or the spigot opening, where the fire spigot goes into. Okay, now again this is a set size and must be checked with the manufacturer's instructions. So the next part of the closure plate is, you can see it's taped on with this grey tape, and you must use this grey tape, not the silver aluminium tape, because that is not strong enough. This is rubbish to start off with, so the aluminium tape is even worse. It's got no strength to it whatsoever. Now this is one of the reasons why these fires, well, every gas appliance needs to be serviced every 12 months, we all know that, but this is one of the major reasons why, because this tape peels off in time. So you don't want this fire being left more than 12 months, so we can retape it. So what we're going to do now is we're going to take this closure plate off, because we're going to do a visual inspection of the FLUE, because again the regulations say we must do a visual inspection first before we carry out our FLUE flow test. So let's have a look now. Now we've removed the closure plate, and the sharp-eyed guys out there will notice this is a precast FLUE. So precast FLUE is made up of different components. The components are starter blocks. Now with starter blocks, according to the manufacturers and the building regs, we require 3 starter blocks. These starter blocks cannot have any mortar fangs, or commonly known in the trade as snotters. That's mortar sticking out, because if they do, it can stop the flue from drawing and pulling. So it can also get spiders, webs can connect onto it, and can reduce the area of the flue. So we can't have any mortar fangs or snorter blocks. Also, the blocks need to be sealed to whatever the wall is. Okay. Now the wall for a precast flue system cannot be plaster. It has to be plasterboard dot and dabbed. Because if it's just roughed in and then actually plastered over the top, it can crack and move the blocks and it can damage the flue system. So it has to have an air gap between the blocks and the plaster. So that's why it's dot and dabbed over. So after the 3 starter blocks, there is a cover block. And what the cover block does is it goes from the starter blocks to the flue blocks, and then the flue blocks are staggered. We'll look at that in a minute. But the flue blocks are staggered and bonded into the wall so they don't fall down. Then at the very top of the flue is a transfer block. And we'll look at them closely in a minute. The transfer block is either an angled one or a straight one. Okay. So that's what the precast flue is made up of. Now we will check now manufacturer's instructions to see what size this needs to be so this appliance can connect onto it. So again, if you don't have the manufacturer's instructions, how do you know what you're supposed to have? So this is why it's so important for these manufacturer's instructions. So let's have a look what the instructions say now so we can crack on with this. So this is the precast flue section in the manufacturer's instructions, and it says the fire is suitable for fitting into properly constructed non-impaired precast flue of a minimum cross-sectional area of 198mm by 67mm or 7 3/4 inches by 2 5/8 inches, which complies with the recommendations in BS 5440 Part 1 and BS 1289 and has a minimum equivalent height of 3 metres or 10 foot. So no open fluid appliance can go on a flue system lower than 10 foot anyway. So it also says about the mortar fangs there, so making sure there's no mortar fangs. So it also says the air relief opening, which we were talking about before in the closure plate, must be increased to 102 by 50mm or 4 inch by 2 inch as shown down at the bottom. So we'll have a look at that again. And the spigot restrictor must not be used. Okay, but it does say the flue cooler plate supplied must be fitted to the back of the closure plate, and then it shows you how to do it. So this manufacturer's instructions is giving you all this information, and this is what we must be working to. So let's have a look at these blocks more closely now. So these are the flue blocks we've just been talking about. So these are the actual flue itself, the actual where the products of combustion come through. This is one on its side, so this is the opening we're looking at. Okay, and I'll show you how they bond together in a minute. So let's take this opening size. So our manufacturer's instructions, which we've got here, it says our hole size here should be 198 by 67 or 7 3/4 inches by 2 5/8. So let's do it in inches because we can see that a bit easier. So if I put that on there, we can see, ooh, 7 1/4. And if we look at it that way, it's 3 1/2. Okay, so that's the cross-sectional area. So let's do a little bit of maths and see what that comes out. Okay, so done a little bit of maths now. Maths not my strong point, remember, or spelling. Good job on my gas engineering, isn't it? Anyway, it gives you a cross-sectional area of 198 by 67, which gives you 13,266mm squared. Now what we've actually got is 185 by 90, which gives you a cross-sectional area of 16,650. So our cross-sectional area is actually big enough for this fire to go on there, even though it's not the exact measurements what the manufacturers did say, but it does say cross-sectional area of. Okay, so as long as it passes flue flow test and spillage and everything like that, then it should be okay. So that's what we're looking at there. Now, how these blocks fit together. Pretty straightforward, really. We've got like a flange on this side here, so you can see like a male end here sticking up, and we've got a female end there. So we would put it that way up, so the male end would be sticking up. Okay. They would then put some sealant on there. Now, 2 things we can seal this with: mortar which bricklayers don't care and don't clean off inside, or there is a special silicone, and this is a special silicone. So you can see that's the special silicone there. So that can be used as well. Okay. So how we bond these blocks is dead straightforward. We would put our sealant around there, and then this would just fit in like that, and it would be bonded that way. So now the bricklayer could tie it in to the wall, and then it would be dot and dabbed over the top. So that's the FLUE blocks. So it's 3 starter blocks, cover block, I forgot what it's called then, the cover block, then the FLUE blocks. Let's have a look at this transfer block. So this is a transfer block we can see here, which you would see in the loft. So this is where the twin wall FLUE system transfers over. But you must pay particular attention on how this is jointed here. So this is actually jointed wrong. There should be, this is in 2 sections, again we'll look a bit closer in a minute, but this is twin wall FLUE. So this is the outer skin, but we should be sealing the inner skin. So this is wrong. If you saw this in the loft, this would be wrong, because products of combustion now can come up this outside. Let's have a quick look at that. So you can now see this is your twin wall. So this is your inner skin, and this is your outer skin. So this is where it was connected in to the block, which is wrong, and it's this inner one which should be longer than the outer one, and we actually seal this inner one. This air gap, this is an air gap what you can see around there. So we don't want products of combustion going up the air gap, which means it can come out of the joints. We want it to go straight the way up the middle. Okay, that's why this needs sealing, not this part. Now, we've had a look around the outside. We can see what we're looking at there, but we need to look inside. Now, one of the things you don't do when you're visually looking up a FLUE is use your mince pies direct. Okay, even with safety glasses, you can still get debris falling on your face and in your eyes. So, never really look straight up using your eyes, use something indirectly. So one of the good ways now with the smartphone is take a video or a film inside and then have a look. But back to basics, you need a mirror and a torch. So you can get the mirror, shine the torch up the FLUE, and then using the mirror you can see up the FLUE. It's very, very good how to do that. So let's have a look inside this. Now let's have a look at this chimney. You can see there's mortar fangs there, and we can see right at the end it looks like it's not sealed properly. Let's try and zoom in there. So now you can see properly at the top, you can see how badly it is actually sealed there. So important that these are sealed correctly. You can see the fire foam, you can see the mortar fangs, you can see this chimney's not in a good way. Now we've done our visual inspections, we've noted all our faults down, we've had a really good visual look at this now, we're probably condemning it before we've even done a FLUE flow test. Now according to BS 5440 we should check and see if it pulls. If it doesn't pull, then warm it up, but we're going to cut the middle man out. We're going to warm it up. Okay, so when we're doing this test, just to recap, we're going to make sure windows and doors are closed. We've got to make sure all fans are turned off and any closers or louvers shut off. Okay, we've got to make sure every passive stack system is turned off too. So we've got our worst case scenario. So we can try with a match to see if it's pulling, because one thing, we don't want to be using a bomb 5 meters cubed over 30 seconds, remember. Pouring a load of smoke back into the customer's house, they're not going to be too happy about it, especially if they've got asthma or any breathing problems. So always use a smoke match first, just to see if there's a pull. Then we're going to use the smoke bomb to check the integrity of the chimney. Okay, remember, this is checking the integrity. Then we've got to go in the loft, we've got to go in the bedrooms, we've got to go outside. So anywhere where this FLUE goes, we need to inspect. So if you're on your own, you might have to do 3 or 4 of these tests, but if you're with somebody, then they can be in the loft, they can be in the bedrooms, they can be outside while you're checking it. So it's not just a straightforward sling a bomb in there and away we go. So, but what I'm going to do is, and what I train here, is always warm the FLUE up first for 5 minutes to give it some kind of pull. Then we're going to use a smoke match to see if it's drawing. If it isn't, we're going to warm it up a bit more, and if it does, then we're going to use the bomb. So let's get on with it. Let's warm this FLUE up. Now we're going to give it a go and see if we can actually get it to work. So I'm going to use our holders, what we make here at Tomcat for the smoke matches. What we do is we light the smoke match and drop it in so it directs the smoke for us. Basically it's a piece of 15mm copper pipe, squashed at one end to stop the smoke coming out of there, and we crank there. So pretty straightforward. Go through, get loads of these go missing. Anyway, I'm going to light the match, drop it in and then try it. So you could see all that smoke was drawn up there. So what we're going to do now is we're going to get a bomb and we're going to try that. Okay, so we've now got a bomb, 5 meters cubed over 30 seconds. I'm going to put it in this holder, and again I'm going to hold it in there so I'm not going to burn on, it's not going to melt my hand. I'm going to light this and I'm going to hold it at the top. Now if I put this down at the bottom, there's every chance the smoke will come out. It will all come out this way. So I'm going to try it like this and hold it at the top. Now one of the best ways of doing this would to be put the closure plate on in front and then go through the closure plate opening. So we're going to do it this way first so you can see it, and then we'll try it that way. So as you can see, even though this is in a poor condition, this chimney, it still passed its FLUE flow test. So what we're going to do now is we're going to get the closure plate on. Let's see what happens with that. Now let's get this closure plate on. How do we know where the closure plate needs to be? How do we know if it's in the right place or not before we tape it on? Now we need to use closure plate tape, and this is a special tape for closure plate. Remember, it's not duct tape, it's heat resistant tape. You need to buy the right tape. And again, do not use this, the silver foiled back tape, what you could use for taping across the bottom, this kind of stuff you can see here. Don't use that for going around the closure plate, it's not strong enough. Okay, so we need to use this grey tape. Now what I do is, first of all, is just rip a little piece off and put it at the top, okay, and then just kind of put it roughly where you think it's going to be, because you might still see the tape, the bits of tape. So what I'm going to do now is I'm going to use the fire and put it back in position to help me to make sure I've got it in the right place. Okay, the fire's in the right place now, so using a pencil I can just pull this apart. I'm just going to mark the corners using my pencil so I know it's in the right place, because my tape is holding it in. So I'm just marking the corners. Now what this is made by the manufacturer, this black thing here. This is a closure plate cover. This is made by the manufacturer to do this because the closure plate actually comes higher than the fire itself in this situation. So we can use this, okay? It's just to hide the closure plate. It looks ugly, but the fire doesn't look that good anyway, does it? So anyway, let's get this taped on. So what I can do now is I can use some more bits of tape just to hold it in place for me while I tape down the sides. And now using the tape doing full strips, I can now go all the way around, including the bottom. We need to seal the bottom to the hearth, okay? We do not cover the air relief, so because the manufacturer tells us what size it is, so we'll need to tape all the way around, so let's get on with it. So while I'm busy taping up this closure plate, let's go through a few things on twin wall flue systems, what you need to know. First of all, if it was say on a boiler, there must be a 600 rise before the first bend, and there must be no 90-degree bends at 45 this biggest bend. Clips must be every change of direction or no more than 1.8 metres apart. Flue liner must never be seen, so it shouldn't be seen on show at the boiler unless it's in a builder's opening or in a loft. So when you do this visual inspection in the loft, you'll look and see if you can see any flue liner. If you can, it's at risk. So any of these faults now, what used to be not to current standards in our unsafe situations procedure, are now deemed at risk. No 600, more than 45-degree bends, clips not 1.8 metres apart, and the flue is unsecure. Yeah, so these are all the things you need to be looking out for. So let's hurry up and get this taping done. Okay, keen-eyed guys amongst you would have noticed a couple of things. First of all, the closure plate was actually not long enough. You can see the big gap at the bottom, so the closure plate has to go all the way down to the bottom. And also, you might have noticed that the gas pipe isn't sleeved. Now, on your visual inspections, gas pipes need to be sleeved through everything now. Plasterboard wall, brick wall, single brick, concrete block, cavity wall. But in our unsafe situations procedure, IGMG 11, it says unless there's any signs of damage or corrosion, you're only deeming it not to current standards or notifiable. And yes, guys, kind of not to current standards hasn't gone. It's just whether you write it in the unsafe situations procedure book or not. Not to current standard stuff, you don't notify anybody unless it's to do with fluids or ventilation. So that's all taped up. I'm going to try now the smoke match again, and then let's try another bump. Now again, according to the 5440, it says if little whispers come out and then go back in, that's fine. But according to the manufacturer's instructions, it says any whispers coming out you could deem not satisfactory. So it's your judgment on that. I would say if anything comes out, you know, be doing it again to make sure nothing comes out. So that's passed again. Let's get another bomb. So I've not even got that in the hole, in the letterbox opening or the spigot. And you can see that's drawing in and got quite a good pull on it. And there isn't anything coming back in at all. And I would deem that a satisfactory flue flow test. Again, I would go in the loft, in outside, checking and make sure we've got nothing coming out. Okay? Looks good to me. So, let's get this fire back on, let's get it warmed up, and let's do the spillage test and go through that procedure. Now, you just finished watching part 1 of this 2-part gas tutorial on flue flow tests and spillage. Part 1 has just covered flue flow testing. Part 2 is going to cover spillage test. So if you've liked this video, why don't you give it a thumbs up and leave a constructive comment down below. If you haven't subscribed to our channel yet, get and subscribe, you won't regret it. And ring that notification bell because every Wednesday we upload videos. Thanks for watching, thanks for listening, see you next Wednesday for the next part.